Welcome to the Section 2, Project 1 Anti-Theft Motion Detector. In this video, getting started with our first IoT project, we will be looking at hardware circuit diagram and then we will write some Python code for sensors and HTTP server. By looking at the basic project overview, we will be making a theft defensive IoT device that will detect motion based on which it will trigger alarm. Also, it will send alerts to the user, which fulfills one-directional communication from the server to the user. And in order to complete bidirectional communication from the user to the server, we will also add a functionality in which users can communicate with the server. In our case, we will add a use case to deactivate the alarm. So PIR sensor is a motion detector module. It has a sensing element called RE200BL. It's a bioelectrical sensor which generates energy when exposed to the heat. That means when a human or animal body will get in the range of the sensor, it will detect a movement because the humans or animals emit heat energy in the form of infrared radiations. That's where the name of the sensor comes from, a passive infrared sensor. And the term passive means that the sensor is not using any energy for detecting purpose. It just works by detecting the energy given off by other objects. The module also consists of a specially designed plastic cap which is used to expand the detection area coverage. The module has 3 pins, the ground, VCC for 5 volts for powering up, and an output pin which gives high logic level if an object is detected and vice versa. Also, it has 2 potentiometers, one for adjusting the sensitivity of the sensor and other for adjusting the time the input signal stays high when the object is detected. This time can be adjusted from 0.3 seconds up to 5 minutes. The module has 3 more pins with a jumper between 2 of them. These pins are for selecting trigger modes. The first one is called non-repeatable trigger and works like this. When a sensor outputs a high and the delay time is over, the output is automatically changed from high to low. The other mode called repeatable trigger will keep the output high all the time until the detected object is present in the sensor's range. A buzzer consists of an outside case with 3 pins attached with it, the VCC 5 volts, the ground and the signal in pin. Inside is a piezo element which is surrounded by a metal vibration disc. When the current is applied to the buzzer, it causes the disc to contract and expand, which then causes the surrounding disc to vibrate. That's the sound that we hear. And if the frequency of the buzzer is changed, then the speed of the vibration changes, which then causes a change in the pitch of the resulting sound. And as a result, we can generate some beautiful melodies like this. We will control the buzzer by generating a square wave. In simple words, we will turn the signal pin high, wait for some milliseconds, then we will turn it low, and then wait for some milliseconds. And then we will repeat the process again. So the resulting square wave will look something like this. This will get much clearer when we will be writing the code for the buzzer. Let's jump in depth of how the project will work technically. First off, we will connect the PIR sensor and the buzzer with Raspberry Pi and write a basic Python code that detects the high and low signals upon motion detection. And then we will write a one-line code to control the buzzer. Secondly, we will write a very basic Python Flask HTTP web server on Raspberry Pi, which will run on our local Wi-Fi network. Let's say the local Wi-Fi router assigned 192.168.1.251 IP address to the Raspberry Pi. Then the user can go to this address from his or her browser, request for a web page, and as a response, they get a web page. Once the user gets the web page, a keep alive request will be sent from the user browser to the Raspberry Pi web server periodically after every 5 seconds. The response of each keep alive request can be considered as a heartbeat to make sure that the connection with the server still exists, means that the server is still alive. On each keep alive response, we will also allow the server to send the sensor status and the data to the user. And that's how a user will get the live updates from the sensor. Then we will add another switch button on the web page that allows the users to control the actuators. In our case, to deactivate the buzzer. Remember that the server is running locally, so users can only access it from within the network. Means that they should be connected to the same Wi-Fi router. So before starting off with the code, I will suggest you to set up your Raspberry Pis by following the official Raspberry Pi setup instructions on their website. You will require a minimum of 8 GB SD card in which you will install the operating system, and you also may need an HDMI monitor. If you don't have the HDMI monitor, you can also do the remote desktop to the Raspberry Pi, as I will be doing. You can follow the simple instructions on the YouTube video provided, and note that for Raspberry Pi 3, the SSH is by default disabled. So you need to enable the SSH in order to do the remote desktoping. For that, you need to go to the terminal in Raspberry Pi and type sudo raspi configs and follow the instructions to activate the SSH.